we're going to talk about how to use the law of cosines to solve a triangle. As you remember, if this triangle is notated as A, B, C with capital letters for the angles, then the side opposite A would be a little a, the side opposite B would be a little b, and the side opposite C would be a little c. So having labeled the triangle correctly, I'm going to fill in my values. I know that my angle A is 40 degrees. I know that my side B is 10, and my side C is 8. And that's all I've got. This confirms for me that I cannot use the law of sines, which would be so much easier because I don't have a ratio of any pair of these matched up. So what is the law of cosines? Well, the law of cosines is quite long. It says a squared equals b squared plus c squared, wait, don't stop there, minus 2bc cosine of angle A. And it doesn't have to be that particular version, because theoretically, I could have relabeled this instead of A, B, and C, I could have labeled it A, B, and C. And the numbers would still be the same, and the triangles would still be the same, but the letters would be in different positions. So there's actually 3 different versions of the law of cosines. One is where you've got an A out front here, B and C here, and then this becomes the matching angle to the side that's out front here. So if I wanted to make it B squared, I would choose the other 2 side lengths in here, and here, and the cosine would be of the matching angle to that side. Or if I were to choose C squared, I would have B squared plus A squared here, minus 2AB cosine of capital C. So those are the 3 forms of the law of cosines. In this case, I am going to choose that first one because, as you can see, I've got my B, I've got my C, I've got a B, I've got a C, and I've got an angle A. So I should be able to solve for A squared pretty easily. So I'm going to say A squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 40 degrees. So A squared is equal to 100 plus 64. 2 times 10 times 8 is 80 to 160. Cosine of 40. I can combine these two because they're both just integers being added, but I cannot combine this minus 160 because this is being multiplied by cosine of 40, whereas this is not. So I actually have to leave it like this as an expression. A lot of people make the mistake of making this 4 times cosine of 40. That would be incorrect. This is a numerical value. If I want to, I can find a decimal equivalent of it by plugging into my calculator. And I get A squared is approximately equal to 41.43288891. So that now when I square root both sides, even though I'm square rooting it and thus I should do a plus or minus, A is the length of the side, therefore I don't need to worry about the minus. So A is approximately equal to 6.436838844. Okay, and depending on where I wanted to round that, I would present it as appropriate. Now what should I choose? Well, I could choose to do this one. This is now a law of sines, right? I've got a pair that matches. Or I could choose to do another one. Let's try doing another one just for practice with the law of cosines. I'm going to do my B, so I'm going to choose B squared. I'm going to start with B squared equals A squared plus C squared minus 2AC cosine of B, and this is going to find for me the value of B. So I'm going to say that 100 equals, well, I know that if this was square root of A of 41, then this would be A squared. So 41.4328891 plus 64, because that's 8 squared. And I want to keep this with as many decimals as possible because there is a rounding error in here. But if I'm good with it and try to keep it as precise as possible, by the time I end up rounding, it won't have a significant impact. All right, so this is 100 equals, these two can be added together, so 64 and 41 is 105.43288891 minus, I need to multiply this out, so 2 times, I'm going to actually store that, okay, so 2 times that times 8. This is 102.989415 cosine of b. And again, I can't combine these two because this is being multiplied by cosine of b. So I'm going to subtract this. So I'm going to get 100 minus 105.4328891, which is going to be negative 5.4328891. Equals negative 102.989415 times cosine of b. I'm trying to solve for the cosine of b. Right now it's being multiplied by this negative number, so I'll divide by that. So that divided by negative 102.989415. And what I get is 0.05275191173 equals the cosine of b. And if I want to find the value of b, I have to undo what's being done to b. Right now it's being cosigned. So I need to uncosine it, or inverse cosine both sides, so that the inverse cosine of 0.05275191173 is equal to b. So b is approximately equal to 86.976. So now I can add that back into my value up here. And although I could continue with law of cosines or law of sines, again, there's a much easier way. I know that all three of these angles add up to 180. So 40 plus 86.976 plus c equals 180. So 126.976 plus c equals 180. So c is equal to 53.024. And just to double check, my smallest angle is facing my smallest side, my middlest angle is facing my middlest side, and my largest angle is facing my largest side. So this was a correct application of the law of cosines. We do have to be a little bit careful after we find the first one that we don't set ourselves up to find the components for one of the ambiguous cases by choosing angle side side snare. All right, thank you very much.